Hi, my name is Maria Jose Lozan and I'm participating in Challenge 2016. In this video, I will be solving problem number 4 from the Calculus Placement exam, which is find the derivative of the function y with respect to t when y equals e to the power of cosine t over 9 to the power of 4. As you can see, the function e to the power of cosine t over 9 is inside another function, and because of this, we have to use the chain rule in order to find the derivative. Let's call the outside function y, which would be equal to u over 4, where u equals e to the power of cosine t over 9. As the chain rule for this function equals dy over du times du over dt, we need to find the derivative of both y and u. To find the derivative of y, we need to use the product rule, which states that when y equals u to the power of n, the derivative of the function y with respect to u equals n times u to the power of n minus 1. Therefore, the derivative of the function y with respect to u equals 4 times u to the power of 3, which equals to 4 brackets e to the power of cosine t over 9 brackets to the power of 3, where u was replaced by e to the power of cosine t over 9. Now, in order to find the derivative of function u, we need to use both the exponential function rule and the chain rule. Okay, we know that u equals to e to the power of cosine t over 9. So if we apply the chain rule here, the derivative of e to the power of w of t, to make things simpler for now, equals e to the power of w of t times the derivative of w of t. W of t is an inner function I have used to replace cosine t over 9 for now in order to show the chain rule for the function we are solving right now. In order to make the next step simpler, I will be calling cosine t over 9 now cosine z of t. Now, using the chain rule, which is one of the differentiation rules we have used previously, we can find the derivative of w of t. Which equals to the derivative of the function cosine z of t with respect to t times the derivative of the function z of t with respect to t. So the derivative of cosine z of t with respect to t equals negative sine of z of t times the derivative of z of t with respect to t, which equals 1/9, as z of t equaled t over 9. Therefore, the final answer is negative 1/9 sine of t over 9. Now we can go back to the chain rule we had at the top of the page and complete it. So, the derivative of e to the power of cosine t over 9 equals to e to the power of cosine t over 9 times negative 1/9 sine of t over 9, which equals to negative 1/9 times sine of t over 9 times e to the power of cosine t over 9. Now we have the derivative of u with respect to t, which I initially referred to as du over dt. Now that we know that dy over du equals 4 brackets e to the power of cosine t over 9 brackets to the power of 3, and du over dt equals to negative 1/9 e to the power of cosine t over 9 times sine of t over 9, we can find dy over dt as dy over du times du over dt gives us the answer we need, as the du's from each derivative cancel each other, so we get dy over dt. So dy over dt equals 4 e to the power of cosine t over 9 to the power of 3 times negative 1/9 e to the power of cosine of t over 9 times sine of t over 9. Now we need to multiply the like terms in order to simplify this equation. Therefore, dy over dt equals negative 4/9 times e to the power of cosine t over 9 to the power of 4 times sine of t over 9.